gravity pulls everything downward. But have you ever thought, why does gravity become weaker when you go higher? Even though it is a long range force and never becomes zero? Hello, I am Advay. Today I will explain this question in a way that a class 11 student can understand and a physics honors student can also relate this. Let's start simple. According to the universal law of gravitation, small g equals to gm by r plus h the whole square, where the capital G is denotes the universal gravitational constant, m denotes the mass of the earth, r denotes the radius of the earth, and h is the height above the surface. As the height h increases, the distance from the earth's center increases, and because gravity follows an inverse square law, bigger distance is smaller value of g we got. That's the basic idea. Now let's step into a deeper physics. When h is related to r like that, we can use the binomial expansion here, where the function of g of h is gm by r plus h square, that is near equals to z naught 1 minus 2h by r. This shows something beautiful here. For small heights, gravity decreases almost linearly with height, and this approximation becomes very useful in satellite and geophysics calculation. If we go more deeper, that is gravitational potential, where it is equals to v equals to minus gm by r, then the gravitational field is the gradient of potential, that is g vector equals to minus grad v, and it is related as, so gravity weakens because the field lines spread out as distance increases. This matches the inverse square nature of central forces. Now if we just let these technical hazards and try to explain these in real world example, even at the height of the International Space Station above 400 km to 500 km above the earth, you say gravity is zero, but that's not the truth, because gravity is still around, where g is near equals to 8.7 meter per second square. So astronauts float not because gravity disappears, but because they are in the continuous free fall orbiting Earth. If I want to add in a deep fact here, that gravity depends not only on height, but also on Earth's surface rotation, latitude, Earth's not being a perfect square. These ideas help explain why G is maximum at the poles and minimum at the equator. So the answer is simple yet profound. If gravity decreases, that means height increases, because the distance from the Earth's center increases and the gravitational field spreads out, but it never becomes zero. That's why gravity is a long range force. So thank you guys. If you enjoyed this physics breakdown, don't forget to like, share and subscribe. Comment below if you want me to explain why astronauts feel weightless or how escape velocity actually works. Thank you.